Hey guys, welcome back to another video. Are you having problems with your AC HVAC unit inside your house not blowing out any air from your vents? Is the evaporator inside your house completely frozen up? The same thing happened to me a few years ago and it ended up being the capacitor. I replaced it for $10. I thought that's what my problem was this time, but long story short, it was not. It was much, much worse. I started off by using a fan to just blow some hot air into that evaporator and remove all of that ice. All right, we are getting 11 degrees Fahrenheit. So I guess it's time to take it apart and let's figure out what's going on. Never buy a double wide. I'm not just saying that because it's 80 degrees in the house. Nothing is standard. Everything is like custom because they use terrible materials. Just never buy it. Yeah, you can see what we're working with here. Dirty. Right there is where, that's what we need in. That's what we need into. Hey, so before you do anything in here, two things. One, this video is for educational and informational purposes only. All risks are assumed by you. I'm just showing you what I would do and what I am doing. Now I'm going to go turn the power off because I don't want to get hurt. So I'm going to make sure that the power is off, off, off. And I'm going to double check it because I don't want to get hurt. Off, off, off. I have my multimeter. We're going to use a multimeter. You want to know what kind, like this is a Miller. Oh yeah, okay, that's how it goes. Take a moment to snap pictures of everything and from different angles. Get all the model information, the voltages, all these stuff that you could see here. Get that from both the blower and the heating assembly if you have a heater assembly inside your house. Take pictures of how everything goes together. Where are the screws? What kind of screws are there? How many are there? Where are the cables? Like the wiring. Where do the wires come from? What do the wires look like? Now what we're looking for, we got to go to the hardware store. We're looking for a 7.5 microfarad plus 6. This one is 370 volts AC. You can go higher on the AC, like 440 is fine. You can go up to a 440 on this. But chances are pretty good that if your blower motor's not running, it's probably your capacitor. It could be other things too, but today we're going to replace the capacitor because I'm pretty sure that that's the problem. It, in fact, was not the problem. Now remember, before you touch a capacitor, make sure you discharge it appropriately. It can still hold voltage. Use an insulating screwdriver, hold the insulated part, and touch it between the two terminals, one on each side. If you have a 3-terminal capacitor, you'll need to touch all 3 parts, but make sure that they're all discharged. When you're picking out a capacitor, it's important to note the MFD or the microfarad needs to match. 7.5, if you see that little U, that's microfarad, that big F farad. 7.5 MFD, microfarad. Same thing. Make sure it's the same volts of AC. If your old one said 370 and the new one says 440, as long as it's higher, it's okay. If it says 240, that's bad. Don't do that. On the AC rating, it can go up. If you get one that's higher, it's better. But it's not better if you've got a higher microfarad. That can blow your motor. A capacitor is just a really big battery bank that is able to discharge all of its electricity, or most of its electricity, very, very quickly. Just imagine plugging up your phone to a battery bank and it went from 0% to like 80%, just like that. It's able to take large amounts of current and just kick-start like a motor, a fan, a compressor, things like that. All right, here we got our capacitor here. We're gonna go ahead and replace it. We're gonna find these 2 cables right there. On this one, it doesn't really matter where they plug up to. On the dual runs, it does matter because you'll have like 7.5 plus 5 or something like that. All right. There was some more water. Oh. No. No. While I figured the rest of this out, I went ahead and put up a fan that my lovely wife ended up having just to dry out this whole area. At this point, I went ahead and unscrewed the blower motor, unplugged the wiring harness, and pulled it out. I also had some water that was not draining from my pan here, and so I found the only thing that I could, which was a screwdriver to dislodge whatever was stuck inside there, and it did look like it started to drain after that. Needed to check between orange and black, blue, yellow, and red, and I was actually checking between red and then all the rest of them. So every wiring diagram is a little bit different. Check your motor, it should have a wiring diagram on it. Now my toggle switch here is set to auto mode for the fan, which means that the fan is going to use varying voltages to regulate the speed that it runs. Now, with it set to auto, I'm going to go through and test the voltages across all these wires. What I ended up finding was that this fan blower motor is a 240 volt motor. All right, here we go. Orange and black. So orange is right there. And black is the high speed wire. Orange is the line in, so we're getting 40 volts. That's orange and black. And then between orange and blue, we are getting 47 volts. And then between orange and yellow, we're getting 0 volts, but that doesn't mean anything. Yellow is the medium-low fan mode, and then red is the low. So we should, we're getting 70 volts between, we're getting 70 volts between the red and orange, and then 0 volts between, that's really weird, yellow. And then, try this again. So 45 volts between blue and orange. And between black and orange, we're getting 38 volts. Between black and orange, 45. Oh, that goes to Alice. That goes to that too. That's good to know. This specific fan model has like a high mode, a medium high, a medium, a medium low, and a low mode, I think. And all of those are different voltage specifications. This one was not getting anywhere close to what it should have been getting, which then points us to what the actual problem was. It appears that the water dripping from above has fried the auto mode switch. When I turn it to on, I get the appropriate voltages. Black, 200 volts of black, 175 volts. Wow. 175 volt to orange to black to blue. So let's look here. 240 volt there. So that's the open one. This is the black one. This is the blue one. 175 volt to blue. 240 volt to yellow. 147 volt to red. Okay, let's flip the auto on. Now let's do it again. 40 volt. 41 volt. 0 volt. 70 volt. Now let's flip it back. $240 volt, 200 volt, 180 volt, 241 volt, 146 volt. It's indicative of a faulty auto on switch. Oh. Okay, well, those are sharp little things. Looks like moisture's gotten in here. It's slightly wet. Probably wouldn't hurt to throw a fan on it and just let it sit, but I'm gonna If you didn't see the capacitor install earlier, this is pretty much it. So that's it. And oh no. Oh. Well, done bent that one, so I guess we'll just plug it up there. It's a good connection, and these are not. Okay, well, there it is. Alright, putting that back on there just like that. And make sure the breaker's still off. Off. Okay. Slide it back in there like that. I'm going to take this connector and I'm going to plug the connector back up. I'm going to put it in the on position. Turn these back on. Turn it back on. Turn it back on. Let's go! Praise the Lord! I want you to remember this sound. I ended up causing a problem when I took the cage out. I'm going to make another video on this topic later, but it involves adjustments and some oiling. So today we successfully diagnosed our issue. We've got our fan motor working again and we'll have AC blowing out shortly. So anyway guys, sorry it was a long video. I thought it was just going to be a capacitor, but try capacitor, may work for you. Don't forget to hit that like button for me and subscribe to my channel for more awesome videos just like this one. Take care. God bless you. Even in that storm, God will bless you. Just believe in Him.